All right, let's solve this polynomial inequality. The first thing we want to do is actually find all the zeros of the polynomial. And we typically do that with factoring. So let's write the first factor again, x minus 4. Second factor is x plus 1. This is a perfect square trinomial. So this actually factors to x minus 6 quantities squared. And we have greater than or equal to 0. Now what we want to do is write the zeros of the polynomial. And so how do we do that? Well, we simply take the polynomial and set it equal to 0. So we could say x minus 4, x plus 1, x minus 6 quantity squared, set that equal to 0. Not a total surprise here. You get 3 zeros, and we should count them in order. So let's say x equals -1 is the first 0, then x equals 4, and then we have x equals 6 with multiplicity of 2. And let's see. What are we going to do with this? What are we going to do with these zeros? We're going to plot them on a number line. So I'm going to draw a rough sketch of a number line here. And it doesn't have to be the scale. So here's another one. And we have 3 zeros. And there we go. We have the x number line. So the first 0 is labeled as -1, 4, and then 6 on the x number line. Now what we want to do is test this inequality. And I'm going to test it here. I'm going to call this triple star. I'm going to go ahead and test that inequality. And we're simply going to pick some x values to do that. So let's try to test x equals -100. And so what would happen to our triple star statement if we have -100? Well, we'll actually get -100 minus 4, which is -104. I only care the fact that that is negative. -100 plus 1 is still negative. And then -100 -100 minus 6 is -106, but then you square it, and that will always be positive. So a negative times a positive is actually positive. So that is actually true. And with inequalities, we always shade the true side. Now, this inequality is true, so I'm going to make a little note here saying, oh, I'm going to shade that. I'm going to eventually shade that true part. Why don't we pick another test point between -1 and 4? Let's pick test x equals 0. That's a good number. So we have negative times a positive. Remember, the 0 is going, where am I putting the 0? I'm putting the 0 here, putting the 0 here, and I'm putting the 0 here. Once again, we have -6 quantities squared, so that would be positive. So what this time we have a negative times a positive, which is still negative. And we're testing to see if that's greater than or equal to 0. Well, that's false. And remember, with inequalities, we do not shade the false parts or the false sides. So let's make a note right here, that is false. So we keep doing this until we actually test all parts of the number line. So what do you think? Between 4 and 5, I'm sorry, I gave the answer away. Between 4 and 6, what should you test? We should test x equals 5. And let's see what we get. So now we get a positive times a what? Times a positive. And then -1 quantity squared is still positive, greater than or equal to 0. So it's a positive times a positive times a positive greater than or equal to 0. That is true. That is a true statement now. Once again, I'm going to label true, or you could just put a T right here to label that part of the number line is true for this triple star inequality. What else? Let's test the last region. You can get a little bit creative here. Maybe test x equals 1,000. Notice it's positive. It's clearly positive, right? 1,000 minus 4 is positive. 1,000 plus 1 is positive. 1,000 minus 6, still a positive number squared. It's clearly positive. So, and if you wanted to be consistent, you could probably put some kind of note for yourself. P times P, positive times a positive. Is that greater than or equal to 0? That is definitely true. Once again, oh, look, we mark it with true. Now, what about our little holes? Do we shade these holes or not? What do I mean by holes? What about these guys right here? Do we shade these? Well, let's see. The inequality says, is this polynomial greater than or equal to 0? So if you test -1 in here, we get 0. Is 0 greater than or equal to 0? Yes, it is. That's true. So we have some shading to do here as well. Let's shade here. What color? How about we shade like this? Whoa. And of course, -4 will make the triple star inequality true. 6 will make the triple star inequality true. And we need to shade all the true parts. So remember, there's a concept of negative infinity over here. We are not shading negative infinity, but we are shading this number line. And we got to shade 4. We did already. Now we got to shade the numbers between 4 and 6. Make sure you shade 6. And then we need to shade all the numbers after 6. And we shade towards the concept of infinity. So let's shade that as well. There's the concept of infinity. So how do we write our answer? Well, we usually write our answer in interval notation. So reading from left to right, we simply write parenthesis on the negative infinity up to -1, close bracket to show that we shaded -1, union, we shade 4, so we close bracket on 4, and we shade all the numbers after 4. And so we'll write infinity and then parentheses again. So there you go. You solved an inequality by shading. That's usually what you do. Hope that helps.